This one's a particularly interesting one. Part A we've shown many times before, so you will have seen this before. If you're in extension 2, you could do it a different way, but again, I think this way is quite efficient. So cos 3 theta we know is 2 theta plus cos of 2 theta plus theta. If we expand that, we get cos 2 theta cos theta minus sine 2 theta sine theta. So if I keep cos theta outside, cos 2 theta, remembering what I'm heading for, it's all got coses in. So cos 2 theta, I want to use the identity 2 cos squared theta minus 1. If I keep the sine theta here, sine 2 theta is 2 sine theta cos theta. So 2 sine theta cos theta, just multiply it by that sine theta. And then again, here we've got, if we expand that out, and we also want to, actually I'll make that, I'll put the cos first, I don't know why I always put that sine first, well I do. Sine squared is 1 minus cos squared, there we go. So in the end we have cos cubed, 2 cos cubed theta minus cos theta minus 2 cos theta minus minus, which is a plus 2 cos, and that's going to be cube theta. So we've got the cube, we've got 4 cos cube theta and minus 3 cos theta, which is what we wanted. So maybe practice that a few times because that seems to come up a lot. Alright, but then this is the interesting part that you know, you'd get maybe on a question 16, and so you know, you can always do parts of it, so don't forget to just try parts of it, even if you can't do the whole question. So B, by substituting, so this one tells us what to substitute in for x into this x cubed minus 3x minus 1. So let's do it, see what we get. Alright, so we end up getting 8 cos cubed theta minus 6 cos theta minus 1 equals 0. Now you'll notice that really part A plus B plus C, we want to use part A. And in part A we've got a 4 cubed with the cubed and a 3 with the single. So you'll notice that this is 8 and 6. Ah, that's nice, same ratio, right? Same ratio. So this is the same as if we divide everything, we want 4 and 3. So let's halve everything. We've got 4, 3, so that'll be, I might put on the other side, that'll be a half. And then now we can substitute this cos 3 theta in here. So we're doing cos 3 theta has to equal a half, so we're solving for 3 theta. Does it tell us? By substituting, show that the equation has roots. Alright, so we want these 3 roots. So where does cos equal a half? Cos equals a half at 60 degrees. It's in degrees here because we've got degrees for the answers. So we've got 60 degrees, 300 degrees, and the next one would be 420 degrees. I can see I want 3. And cos is positive, so we want the first quadrant, fourth quadrant, and back to the first quadrant. Alright, that will mean theta equals, if I divide by 3, we've got 20, 100, and 140. But remember, this is theta, and we are solving, as it says in the question. We're solving for x, because we want the roots of this equation, x cubed minus 3x minus 1. Now, x was 2, is equal to 2 cos theta. So my x's then would be 2 cos 20, 2 cos 100, and 2 cos 140. Which, if we have a look at it, we've got the 2 cos 20, we're all good. So why does the 2 cos 100 look like 2 sine minus 2 sine 10? Alright, so just remember that cos theta is the same as sine 90 minus theta. They're complementary. Remember, they're a 90 degree phase out, the sine and cos. So if I'm saying cos 100, I'm really saying sine 90 minus 100, which is the same as sine of negative 10, and sine is an odd function, so I could also write it like that. Of course, this one's got a 2 out the front, so it'll be a minus 2 sine 10 for that one. And what about this 2 cos 140? How does that get to minus 2 cos 40? So if you think about it, 140 degrees is in this quadrant, so and we know it's going to be negative. But how about I use so that's 140 degrees, so that means that's 40 degrees there. So if I use the acute angle, which is in this quadrant, of 40 degrees, I just have to remember that in this second quadrant, or stations, this is going to be negative. So it's going to be a negative 2, but I can use the acute angle. So it's going to be the same as negative 2 cos 40 degrees. So that's B. Now, you'll note we really, when they told us what to sub in, it worked nicely because we got an 8 and a 6, which is in the same ratio as this 4 and this 3. So for the next question, we've got to be a bit careful of what we use to do our substitution, because we want that same ratio 4 to 3. So it says use a similar approach, but this time it's x cubed minus 12x. So, if I put in a 2 cos theta, I'm going to get an 8 and a minus 24, so an 8 and a 24, which is not in the same ratio as 4 to 3. If I put a 3 in, I would get a 27 to a 36. Again, that doesn't work. What about if I put a 4 cos theta in? I think that works, so let's try it. We would get 4 cubed is 64, and that would be also cubed, and 48 for this one. And 64, 48 is in the correct ratio. It's still in that 4 to 3 ratio. So we're all good there, I think. Yes, we are. All right. What about the rest of it? Yes. So we've got it equals to 8 root 3. And clearly I want 4 cos cubed theta. So I've got to divide by 16, everything by 16. So that'll get me the 3 cos theta, and if I divide by 16, that'll get me root 3 on 2. So from there to there, I'm dividing by 16. Alright, so I should have really said let x equal 4 cos theta. So I just had to figure out what I could sub in to get the ratio that I wanted, because I know I want to substitute in for this part cos 3 theta. Alright, it does say 3 real roots, so I'll do the same thing we did before. So to get our root 3 on 2, did we already do that? Root 3 on 2, so we've got 30 degrees, that's right, isn't it? And 330 degrees and 390 degrees, I think that's right. So our theta will be 10 degrees, 110 degrees, 130 degrees, if we're just looking for the first 3. Now remember that's theta, but we're solving for x, and remember we said x is equal to 4 cos theta, so that would be therefore mean that our x's are 4 cos 10, 4 cos 110, 4 cos 130. Again, well, it doesn't say, yes it does, it says, if I read the question, which I rarely do, which I should, correct to 3 decimal places. So we need to just, this time at least, just put that in our calculators. They're in degrees, so just be careful there. So cos 10, where's my calculator? Alright, so 4 cos 10 degrees is 3.939 to 3.939, that's to 3 decimal places. 4 cos 110, we've got negative 1.368, and then 4 cos 130 is negative 2.571. Anyways, the process is the most important, so just make sure you understand that process.